Hello, good evening. Today the course will be the basics of sand casting, metal casting involved, metal casting done by sand casting. And here uh, we are now showing the complete mold, the final output that is going to come out by first showing how the way the molten metal is poured into a cavity, and then the solidification is taking place. The different parts that are involved during the pouring. The metal cavity is the one that is, this is the cavity shown by this mouse pointer. The ladle, the molten metal being poured. This is the mold made of, in case of a sand casting, the mold material happens to be the sand itself. Normally, steel castings are poured into castings. The steel castings are done by molds that are made by sand material. Mold is made of sand material. This is the one in the sand casting. This thick line may be a wooden flask or sometimes a steel flask. Casting is the final solidified part we target to make. The final solidified part will just, it has been partially filled up. Final solidified part will occupy anywhere between, from here it comes over up to here. What is a casting? A metal casting is a casting means the pouring molten metal into a mold cavity, and the cavity will have the shape to be made and allowing it to solidify. After solidification, the desired metal object is taken out from the sand mold, either by breaking the mold or taking the mold apart in case of metal molds. The solidified object is called the casting. By this process, intricate parts can be given strength and rigidity frequently not obtainable by any other manufacturing process. The intricacy is so high that the shape cannot be achieved by any other manufacturing process. The mold into which the metal is poured is made of some heat resistance material. Sand is the most often used as since it resists the high temperature of the molten metal. Permanent molds of metal also can be used to cast products. Some of the metal castings we can see, look at the intricacies. Talking about the intricacies, you see here, this is an engine block for a 6-cylinder engine. We can see the 6-cylinder engine, the passage for the crankshaft, the end covers with holes, appropriate holes, they will be mounted here. The bearing holes, rolling element bearings will be coming over here. You can look at the intricacies, and even the casting itself has lot of cavities within themselves, lot of no metal area. Such things are easily achievable only by the casting process. Similar examples for casting are engine casting, cylinder head, end brackets. For example, the machine frames, lathe bed, lathe headstocks. Wherever the housings are required to accommodate some other machine elements, castings are planned. These castings will be mostly made of cast iron. Now let us identify which is the open mold and which is the closed mold. Let us see. Let us complete the closed mold. The molten metal will be directly poured into this cavity right above it. Here we are not directly pouring the molten metal into here. Probably we are having a funnel through which we allow the vertical downpour of the molten metal. It hits over here, then the turbulence gets arrested. It has a horizontal smooth flow, then it smoothly guides into this cavity. After filling up, the molten metal rises here. The pouring foundry man can use this riser, what we call the mold element called the riser, as the indicator to give the signal of stop pouring. And it is to be mentioned that this is called the core, and this core, because of the presence of this core, this is also made of sand material only, but of slightly higher quality, having more strength than the basic mold material. Because of the presence of this sand core, whatever the molten material that comes over here, they just go around it and get it filled up, and after solidification we will end up in a through hole. Now for the answer to this question, the students can very well guess about it. This is an open mold and this is a closed mold. Here all the surfaces of the casting will be straight. It is supposedly, at least, that the top one has been planned to be slightly curved up. Here in the closed mold, the top surface also has to be, it is planned to be straight. There is a question, why do we need to plan a core in the mold design? How its overhanging effect is compensated? The overhanging comes into picture whenever this core has been planted somewhere here. Half of it has been planted here, the half is protruding like this. This is in the case of blind holes. The different terminologies involved on a mold. The flask, which is a metal or wooden frame without this flask has no top or bottom, only a skeletal sides only. Depending on the position of the flask, the mold structure, it is referred to by various names such as drag, the lower molding flask, cope, the upper molding flask, cheek, which is an intermediate molding flask used in a three-piece molding type. Sorry. A pattern is the replica of the final object to be made. The three-dimensional replica. The pattern is needed to be made. This pattern is really needed to make the mold cavity to give the impressions. We can call it as a template. A parting line. This is very important in the preparation of sand molds. This is the dividing line between the two molding flasks. Normally here I have to say that the usage of the third flask called the cheek, it's not very popular. This is used only in case of very complicated castings that have a lot of interfering designs. So this parting line has to be on seeing an end engineering component. The foundry engineer has to design the parting line for the casting. So this parting line, mostly it divides the casting into two halves. Sometimes it can be achieved. The parting line can reach the top line of the casting itself. Molding sand, the basic sand by which this mold will be made. It is a mixture of silica sand, clay and moisture in appropriate proportions. Facing sand, a small amount of carbonaceous material sprinkled on the inner surface of the mold cavity to give a better surface finish to the final casting, which is the final product. Let us continue with the mold terminology. Mold terminologies. The core, what we have seen in our previous the core is there. The pouring basin, this is the one that has been here. This is the vertical spur, because we are going to pour probably if at all the opening mouth of this sprue is slightly wider, it's easy for pouring business. That's why this will be slightly widened and has been named as the pouring basin. This vertical hole is called the sprue, S-P-R-U-E, sprue. And here, this is the choke area. This horizontal runner, it has, even though you can blindly call it as a runner, it's a good idea to always, at least in your mind, you can call it as a horizontal runner. And it runs, the molten metal runs, it runs horizontally. Finally, it has to enter into the cavity through the gate. So at the end of this runner and at the beginning of the cavity, we call it as, we have named it as the gate, through which the molten metal glides down. Repeat, it is not poured down, it glides down all the way over here and just fills it up. Then later, after filling it up, the molten metal rises, the red hot molten metal rises up here. The pouring man will get indication. There's the runner has been told, the gate has been told. What about the chaplets? These chaplets are the supporting members made of metal, which will be kept inside the mold cavity in case some cores are planted inside. Some portion of the cores, if you want to give them some additional support so that they will not get dislocated or disturbed while the hot metal is being poured out, we can give supports to these cores by means of some small screws like elements. This can be very well understood in the forthcoming slides. Riser has been already told. Vent, this is nothing but very small tiny holes, probably of 1 mm diameter, which will be pierced all right on top of the mold cavity area, so that during the time of hot metal pouring, the moisture that has been converted to steam, they will find it easy to come out of the mold through these vent holes. Otherwise, they will create problem by trying to enter into the molten metal that has been just freshly poured into this cavity. There is a sequence of steps in the production of castings. In such a sequence of steps, it's whether it's of a metal casting technology or any electrical circuits, whatever is the case, it's a good idea to directly go into the final product of this. This is the final casting. In order to have the final casting, we have to do some cleaning up on the casting, but before the cleaning up, it should have reached the stage of removal of the sand. The sand mold would have engulfed all the casting, solidified casting, and before that, solidification should have started, solidification and cooling. And in order to get this solidification, before that, we should have poured the molten metal into the mold. Pouring the molten metal, that means molten metal must be ready. Molten metal should have been ready. The mold also should have been ready. That's why it is called as mold making here and the melting here. In order to do the melting, we will be needing the raw material here. And in order to manufacture the mold, we should have had a pattern. Normally in sand casting, it is wooden pattern. That is another big industry that is going on. Manufacturing the pattern is a very big industry, looking lot of intricacies. This mold making needs not only the pattern, it also needs the preparation of sand. In order to prepare the sand, we need the sand. The core is also has to be in the event the core has to be planted into the mold. We need the core. The students can very well look the position of the core where it is joining. After making the mold completely, before pouring, the core is coming and being assembled. This is some important point to be noted. Different types of casting. Different types of casting. We can say sand casting. That's what we had seen all the way so far. Not only the sand casting, there is shell molding. Actually, sand casting means casting made out of sand molds. Next one is this shell molding, investment casting, die casting, centrifugal casting. The sand casting we have seen. We can also see, the students can also get into the YouTube in order to see so far we had been doing exercises in our foundry laboratory, doing all the mold making by means of our manual methods. Now in industry, in mass production, manually ramming up all the sand material is very difficult and time consuming, and it won't be uniform too. In order to eliminate this manual human effect, jolt squeeze machines are available and they are being used. The students can have a look at the YouTube just to give a startup. Yeah, an address has been given and you can refer to this. A link has been given. Now let us see the way a sand mold will be prepared. The final casting output we want is something like a brick with a hole, with a central hole. Of course, I haven't dimensioned. We are now read about the shape of it. How to achieve this shape, that's what we want. Finally, this is something like a brick shape with a central hole, a through hole. This is the top view, this is the front view. There is, in order to produce this kind of final casting, we will be needing a cavity like this with a central core. Therefore, we can get a brick with a central hole, brick shaped casting with a central hole. In order to achieve this, we will be needing the pouring here, the vertical sprue. Of course, the pouring basin has not been shown up here. Vertical sprue, the choke is here, horizontal runner. You can very well see the cross section of the horizontal runner is made gradually in a reduced manner only to encourage smooth flow, smooth gliding of the molten metal through the gate right into the cavity. There, the molten metal is being poured. It is glowing. The level is rising. Stop pouring the hot metal. Then the molten metal will also rise over here up to the, which has not been shown with the red color, but however the students can know very well that the molten metal is up to here as well as here. Wait, let it solidify. Let's assume that we are giving a solidification time. After solidification, we have to knock out all this sand. We have to knock out all this sand, including this. Finally, the solidified casting will look like this. Even though the real brick-like structure, brick-like casting with a hole, we want shall look like this only. In fact, the students can very well see that the sprue, the horizontal runner, and the riser also gets solidified because there has to be some metallic remains during the pouring. Therefore, they also will get attached. Later, it will be, the casting will be what we call a cleaning and finishing operation. We will hacksaw it up by maybe a power hacksaw, then followed by some grinding operations in order to finish remove some fins and sharp corners. Pouring, metal pouring, how it is poured in a factory, in industry. The photograph is there, you can see. The crucible is there. The molten metal is being poured up into a pouring basin. One, two, three risers. Look at the mold material, the mold flask. The different steps in casting. This is just the explanation of whatever the flow chart, the block diagram, which we have seen in the steps of manufacturing, the finally reaching the stage of a final casting. The same thing has been written over here. Pattern making, core making should have been done. Molding, the molding means arriving at the exact mold cavity with all the sprue, runners, gates, and the riser. Everything has been finally prepared. Then finally melting and pouring, allowing the solidification and knockout later, then final cleaning. This is the sequence. Let us finally end today's class with marking out the different parts by yourself. I have intentionally, I haven't marked it, I haven't put a direct, for example, I have not marked the parts directly. I could have put an arrow from here, mold flask, over here up to here, which I didn't do. Let me expect the students to take this challenge themselves. Please identify the mold flask, molding sand, molten metal, crucible, crane, pouring basin, sprue. There is a remark here. Please mind these remarks. Gate, runner, riser or risers. Let us have a break now before. Thank you for this.